Hello student, our this lecture is of physics standard 12 and our chapter number 4 moving charges and mechanism. This is the fourth chapter and our video number is also 4th of a chapter number 4. So this is the fourth video of chapter number 4 and the topic is cyclotron. We have discussed some things about a cyclotron in our previous chapter up to the cyclotron frequency. So this is the formula of cyclotron frequency, Vc equal to Qb upon 2 pi m, and one another frequency which is used here is called Va. So the frequency Va of applied voltage. So Va is the frequency of applied voltage. The voltage which we are applying here, that should be equal to the frequency of a cyclotron frequency. So both the frequency must be matched. Va must be equal to Vc. So both the frequency will be the same. So here frequency Va of applied voltage is adjusted so that the polarity of the disk is reversed. Whenever the charge is coming out from one D, the another D should be of opposite charge, so that the charge can be easily go into the another disk. So both the frequency must be equal. So D is reversed in the same time. That is takes the ions to complete one half of the revolution. Whenever charge comes out from 1D by revolving one half of a circle and it is come back into this gap which is between two D's, the another D's must be of opposite charge that of this our charge, so that the charge can easily go into the other D's. So in this way the charge repeating the revolution in both the D's. Second, Va equal to Vc is called the resonance. Here both the frequency, Vc is the frequency of cyclotron and Va is the frequency of applied voltage. Both the frequencies must be the same, and this event is called as resonance. So this is called resonance when Va equal to Vc, both the frequencies are same. The phase of the supply is adjusted so that when the positive ions arrive at the edge of B1, B2 is at lower potential and the ions are accelerated across the gap. Whenever charge comes from B1 and comes here in the gap between two D's, so if the charge is at higher potential, then the other D should be at the lower potential, so the charge can be easily go into the second D. Now its kinetic energy increase QV times whenever they cross from D1 to D2. So its kinetic energy, as the charge repeating the circular motion, the radius and the kinetic energy of the charge will be increased. So the radius will be increased and the circle becomes larger and larger. So radius goes on increasing, the path of that charge particle will be increased. So we have the formula R equal to mv upon qb, where the R is the radius of the trajectory at exit. So we can derive this formula from that V equal to QBR upon M, where M is the radius of R is the radius of the trajectory at exit. Hence the kinetic energy of an ion. How can we find the kinetic energy from this formula? So we have the formula of kinetic energy 1/2 mv square. So here we have the value of V. If we we square this value, so V square equal to Q square B square R square upon M square. So we have the value of V square, and if we multiply it by 1/2 M, so we can get the value of kinetic energy. So if we square this value and multiply it by 1/2 M, so we can get the value 1/2 mv square, which is the kinetic energy of a ion. So 1/2 mv square equal to 1/2 m into this is the square of V. So we have the value 1/2 mv square equal to Q square B square R square upon 2m. This m and here 1 time m will be cancelled. So this 2 into m will become 2m. This is the formula of kinetic energy of a charge. Now use of cyclotron. What are the uses of cyclotron? So here we have given three most important uses of a cyclotron. One use we had discussed about that use in our previous chapter, that it is used to bombard the nuclei with energetic particles. In nuclear fission process, we use the cyclotron for bombarding neutron on a iron nucleus. Second use is to implant ions into solids and modify their properties. If we want to modify the properties of any ions, so we can use the cyclotron for bombarding neutron or small nucleus on that higher particles. And the third use is it is used in hospitals. Cyclotrons are used in hospitals also. So it is used in hospitals to produce radioactive substances which can be used in diagnosis and treatment. Cyclotrons are used for diagnosis and in some treatments also. So these are the three most important uses of cyclotron. In the examinations, the question can be asked that write down the uses of cyclotron, and the mark will be 2. So in 2 marks, this question can be asked that write down the uses of cyclotron, and also you can ask that derive the formula for the kinetic energy of a charged particle, or we can derive this formula from this formula Vc. So this is the formula of kinetic energy of a ions or charged particle. So these two questions can be asked in the examination, and these are very easy and simple questions. This figure is also important for the questions. These are 2Ds, and here we leave the particle and it starts with circular and spiral motion, and at the end, when the radius of its path will be equal to the radius of d, then it goes out from this disc and it is bombarded on the higher nucleus. So it is used. So this is the most important and very important formula, and this question is also asked in our examination that write down the uses of cyclotron. This is the very important questions according to the examinations. Thank you.